IEEE Student Branch SRINT and IEEE PLS Student Branch Chapter SRINT and whole group of institutions, SR group of institutions, especially on behalf of our Chief Patron Sri Pawan Singh Chauhan Sir, Vice Chairman Sir Sri Piyush Singh Chauhan Sir, and our respected Director Dr. DP Singh Sir, and HODs and other colleagues. It is my great pleasure to welcome all the distinguished guests, faculty members, IEEE members, and dear students to the IEEE PLSA 2026 celebration. This year's theme is Powering a Sustainable Future, highlights the transformative role of power electronics, renewable energy, sustainable technologies, and smart power systems. We are deeply honored to have with us Professor Ashish Kumar Singh, Chairman IEEE PLS Chapter IEEE UP Sir, as our guest, his visionary leadership, unwavering commitment to the IEEE community, and continuous efforts in promoting technical excellence among the students and professionals are truly inspiring. We are grateful for his gracious presence and valuable support. We are equally privileged to welcome our uh, honorable guest of honor, Professor Sanjiv Kumar Sir from Harcourt Butler Technical University, Kanpur, a distinguished academician and researcher. His contributions to engineering education and his dedication to mentoring young engineers have greatly benefited to the academic community. We sincerely appreciate him for taking time from his busy schedule to share his expertise with us today. IEEE PLS Day is not only a celebration of technological innovation, but also an opportunity to foster learning, collaboration, and professional growth. I am confident that today's program will inspire all participants and provide valuable insight into the exciting developments shaping the future of power electronics and sustainable energy. I extend my heartfelt thanks to all our guests and participants for joining us today and making this event a success. With these words, I once again welcome you all and wish you a very informative and inspiring session ahead. Thank you.
Thank you,
Now,
sir.
Akansha,
Okay, thank you, sir. Up next, we have a personality who seamlessly bridges the gap between complex engineering and student mentorship. Let us give a warm, resounding welcome to Professor Sanjeev Kumar, sir. Apart from being a senior professor in the electrical engineering department at HBTU, he steers the university's global footprint as the Dean of International Student Affairs. To the student community, he is a familiar guide and mentor, severing activity as the IEEE student branch counselor and share his immense knowledge digitally through his popular channel Power Electronics by Dr. Sanjeev Sir. From securing a spectacular 99.09 percentile in GATE to leading cutting its research in power converters. Sir's journey is a blueprint for excellence. Sir, we are eager to be enlightened by your words. Please welcome, sir.
Thank you, Akanksha, for such a wonderful introduction of mine. First of all, I am thankful to Moin Saab who invited me for this talk and welcoming to our chief guest, Professor Ashish sir from MNIT. And I congratulate to entire team of IEEE student branch of SR Institute of Technology and Management for organizing this one-day workshop and on the occasion of Power Electronics Day. As I can see, so many audience have already joined to, so without wasting the time I just come to the topic of my talk, that is integration of solar PV system with grid. And this talk contained introduction, solar PV system, grid integration of solar PV system, grid integration topology, challenges and limitation of grid integration, solution for grid integration problem, and one more thing, I have also taken the that MATLAB simulation of that DC grid. That I have not mentioned because that totally depend upon the time. If time permits, then I'll show you that those slides to you. Otherwise, I'll conclude the last topic. Right. So let us begin with the grid connected PV system. It is also known as on grid solar system. Right. See, nowadays everyone is talking about the renewable energy, and there the solar, wind, biomass, different type of non-conventional source come into picture as a source of energy. So, for today's topic, we have taken one source, that is the solar system, right? So, a grid connected PV system, it typically consists, which you can also see in the figure, that is solar panel, that is the source of energy which extract energy from the solar and provide us. So solar panel, then we have inverter, then charge controller, then monitoring system, then electrical distribution panel, through which this extracted energy is to be distributed, right? So I hope my voice is clear and very much audible.
Yes, sir. Your voice is
Yes,
very
sir.
much clear.
Okay, fine, fine, fine. So actually, just give me a second. Is it in full screen?
Yes, sir. It is in the full
Full
screen.
screen, fine. See, Moin Saab, these are the constraints which are introduced in the online lecture, because what I am presenting, I am not able to see. Right? That is why I am asking.
We
Okay,
will intimate you, sir, if there will be any problem.
fine,
Please
fine, fine.
proceed.
So, if we talk about the history of this, that means when this solar and all those things are started, then it is started in very very ancient time. In 1954, that Bell Lab developed the first practical silicon based solar cell. It was developed by Bell. Then in 1970s, during the energy crisis, renewable the researchers are started thinking about the this alternative sources, and there the solar power come as the transform. Just give me a second. Just give me a second. Just give me a second. Let me full screen here as well, so that I can also see the things. Just give me a second. Just a second. Now here. Okay. So in 80s, that solar panel developed for grid integration. Not only developed, it successfully deployed for grid integration. During the 1990s to 2000, advances in inverter technology and establishment of this grid code for successful power conversion and feeding to the grid is started. Then we think about the policy driven growth, means how that tariff could be charged from the customer. For example, nowadays, if you generate the energy, you have to integrate with the grid, and you take the power from the grid for your use, and then you feed the power to the grid which you extracted from the source, like solar. Then there is a net billing system comes in the existence. So all these things come by applying these policies which were implemented for this solar power integration and all, right? And it is adopted globally, right? To it means, I mean, everyone is thinking about the adoption of this solar. The reason is that we wish to reduce the carbon emission and all, right? So in that sense, this technology is nowadays mature and advancement is going on till date. I have shown the data up to 2022. There you can see it is started. The first solar cell was created in 1839. Then 1883, the first functioning solar panel come in the picture. Then 1888, first US patent come in the picture. Then 1901, first US patent for solar panels. Then 1905, the state in the introduction, the photovoltaic effect. All these come, this is the pictorial view, and the session is live, so I am not going to just giving you the history. Now, the next is, I am just skipping this all history. The reason is it will take time and I don't have that much time because only 1 hour is allotted to me by Moin Saab. So I am just skipping this history. You can take it from any literature, as well as this session is also live on YouTube. So you can take it from there itself, right? So now come to the basic principle of this photovoltaic solar panel. It's based on the photovoltaic effect, which enables solar panels to generate electricity by converting sunlight into electrical power through the movement of electrons in a semiconductor material. It is the basic principle behind this solar cell and all. If we talk about the structure of solar panel, it consists of photovoltaic cell, that is the unit which converts sunlight into electricity, and it is made from the semiconductor material. Uh, Primarily it was silicon, now people are thinking some other material as well. Then it is covered by a glass cover which protects the cell from the environmental elements while allowing sunlight through this. Then it has frame which provide the structure. Then backsheet insulated and protected cell from moisture and damage. Then the various type of solar panels are monocrystalline solar panel, polycrystalline, and the thin film solar panel. If we talk about the monocrystalline solar panel, it is very high efficiency and long lifespan, but it made of single crystal structure, occupy less space. Then we talk about the polycrystalline solar panel. It is having a lower efficiency and cost, made from multiple silicon crystal. And in case of thin film solar panel, these are very lightweight and they are very flexible, made from thin layers of semiconductor material, and its efficiency is very less and lifespan is also very less. Now if we talk about the grid connected solar PV panel, then you can see there are solar panel array, means several solar panel are either connected in series or in parallel depending upon the requirement of voltage and current. Then there is a converter which convert, of course there would be in between boost converter is also there. Then this converter get the desired DC link voltage. Then once you have DC link voltage, it has to be converted to AC, and this AC is used by the household stock, like your lightning load or AC or something else. And if some power is left out, then it has to be routed to the grid through electricity kWh meter. Kilowatt hour meter means the active power you are feeding to the supply. And this you can see, let me take the pointer, this. You can see it is the, sorry. It is the bidirectional. It is the bidirectional, means you are giving power from here to here. You are feeding the grid, and you are also taking from power from grid for these appliances, right? It is like this. So net metering is applicable there, and you have to charge for net electricity used by the supply. Clear? Now we talk about the function. See, this the function is organized for IEEE student. So I believe that so many electrical engineering student of third year, final year are also joined in this workshop. So I'll also touch the brief functions of whatever you have studied in third year during your power electronics. So inverter is one of the component. Hopefully it comes in your unit 5. There, this is used to convert DC into AC. Then there is also another converter is used, which is the MPPT used for maximum power point tracking. See, depending upon the radiation, that means the energy which is coming from the solar, it keeps on changing because the position of the sun is changing. So what you have to ensure, that the maximum harvesting of energy has to be done. That means it should be operate at maximum power point, means where you can extract maximum energy from the sun, right? Then there is a grid connection which is used to fed power to the grid. Means you must heard about the, if you synchronize with grid, the three component has to be ensured. That is, one is the phase sequence, another which is known as the synchronization of phase, right? Other is the frequency, and third one is the voltage rating. All this you have to ensure. Your solar panel which is giving supply to the grid, that must be have the same voltage sequence, same phase sequence, same voltage level, as well as the same frequency. Then you can synchronize with the grid. Then safety measures should be taken. It includes the anti-islanding protection to disconnect from the grid during power outage, protecting this utility vessel. Means suppose there is a power outage, then your solar should not feed power to the grid, right? Those type of thing has to be taken care. Now if we talk about the type of inverter, the first one is a string inverter, which is commonly used in the residential installation. It connects multiple solar panel in series, and these are the very cost effective, but can be affected by shading or malfunctioning of one panel. Suppose your one panel get damaged, or one panel is giving the malfunction, then the entire setup is turned down. That means stop. So that type of thing has to be taken care in mind. Then we if we consider this the second option is micro inverters, in which installation on each individual panel and also allow panels to uh, operate independently mode, right? Then maximum energy production. Moin sir, my voice is coming.
सर वॉइस इज कमिंग बट थोड़ा स्लो हो गई है.
Okay. Just give me a second. Now is it coming? Is it coming properly?
Yes, yes, now it is coming excellently.
Okay, fine. So, if we talk about the power optimizer, then this power optimizer work with string type of inverter, and each panel has a power optimizer to maximize output. It also combines advantages of both string inverters and micro inverters, right? Now we can characterize on the basis of mounting, how you mount the solar panel. The first one is fixed mounting, which you usually see on the rooftop of our universities or household or everywhere. These mount secure solar panel fit at the particular angle where you get the maximum power from the sun. Right? It is the cost effective, but depending upon the seasonal change, because the sun position of the sun is changes depending upon the your winter, summer and all. right? But since the panel is fixed, you cannot change. Now, second category is adjustable mount. It allows the seasonal adjustment, means depending upon the angle of the solar panel, you can change the position where you get the maximum power from the solar throughout the year, right? Now we talk about the recent development in the grid connected solar PV system. Nowadays smart grid come in the smart grid technology come in the existence, right, where we have to take care of energy management and the grid stability through the real time monitoring, right. We keep on checking the voltage frequency of the grid as well as the solar system, and depending upon the scenario we have to take the suitable action, right. And we also seen the development in the solar PV material. They now the introduction of very efficient material beyond the silicon that are more sustainable, right. Probistic solar cell, they are the having the higher conversion efficiency and low cost production. These are the some ongoing advancement in the grid connected integration of this solar panel, that the nowadays transparent solar panels are coming. They are having the dual functionality. Now color solar panels are coming in the picture. Bifacial solar panel are now getting very populated popular nowadays. It means both side of the solar panel there are solar cell, right. That type of things are coming in the picture. And the recycling of the solar panel is very difficult, so people are researchers are also working on that, and improving the technique to recover the reuse valuable material and reducing the waste which was generated using the solar panel, right. Now if we talk about the manufacturing technique, that 3D printing also introduced, which reduces the cost of this solar panel and all. This I have already covered, so I am skipping this slide, that introduction of solar panel. Now if we see the entire scenario of grid connected solar panel, this is the standalone system where you can see that there is a solar panel and power is flowing from here to here, and these are the voltage and currents need to be sensed, and it is fed to the MPPT, that is the maximum power point controller, and this controller send the signal to this DC to DC power converter for duty cycle control, and the power is feeding to the load. Here we have connected this, see, from here we can go anywhere, means the load can be your DC type load, or it could be a AC type load. But what you have to do, you just connect one inverter after you are getting this DC link voltage, constant DC link voltage, which is operated at the maximum power point control. Means after applying this controller, if you are getting here DC link voltage, that means the maximum energy you are extracting from the solar panel. That's it, right. So this I have already covered. Now if we talk about the various techniques used for the maximum power point tracking, these are the some techniques which are curve fitting, or the fractional short circuit current, or the fractional open circuit voltage, or perturbation and observation and hill climbing, or incremental conduction. These are the very famous technique. Those who are working in the field of power electronics and solar, they know these are the very simple techniques which are widely applicable, and each techniques are having their own advantage and disadvantage, right. I'm just throwing the various aspect of this solar with the grid integration, right. Now if we talk about the solar panel, this I have already introduced, and if you wish to go through more on this, you can take it from the lecture itself, and or you can go through the references, right. This definitely I'll like to discuss, that the environment, if we talk about the environmental benefit, that is reduction of greenhouse gas emission, minimization of pollution, and reduction in habitat destruction. So these are the environment benefits. These are the environmental benefits. And if we talk about the economic advantage, they are lower energy bills, job creation, and price stability. Right? See, this job creation, although this is not the technical aspect, the job creation means if we create solar energy industry, then definitely some job will also be created. Then we talk about the energy independent and security, that it reduces the dependency on fossil fuels, because sun is not going to vanish for long time. So sun is always available. It can be believed. So if the energy is coming from the sun, then there is no tension of this fossil fuel and all. Then it also enhances the resilience. Then accessibility of remote area means solar is available everywhere, whether you go to hill or go to sea, no matter where you are. Then the technological innovation and progress, that the technology is advancing very fast. Integration with the smart grid is also possible nowadays. Now we talk about the limitation of this PV system. The limitation is intermittency and weather dependency. See, it totally depends whether sky is cloudy or not, whether it is in night. uh, it is not possible to generate solar energy in the night, during night time, right? So it is not possible. Then season variability is also there. Suppose it is the rainy season or it is the winter, then it is very difficult to have the sun energy, solar energy. That is the limitation of solar energy, right? Now, high initial cost. It- See, the capital cost of solar is quite high. Installation expenses, energy storage cost means you have to have used some battery, that energy storage system, which store, because see, it is not possible that all the time you are using the entire energy. So that the battery has to be used, which is used to store the energy extracted from the solar panel, and then as per your requirement you can use that stored energy. It also required a large space. That is the another limitation of the solar, that it required the space, large space. It is being required by the solar panel, right? And it is suitable for rooftop, right? Then energy conversion efficiency, that efficiency is also limitation. Researchers are working how to improve the efficiency of conversion. Now grid integration of solar PV system, and if we look at the grid integration aspect, then it maximizes the renewable energy benefits, right? That it maximize. Let me take some different color so that it would be visible. Let us take this. Okay. Then it ensure the reliable power supply means you take the power from solar, then it is good that it ensure the this reliability of this power supply. It facilitates the sustainable energy transition, right? It enhances the grid resilience and stability. It supports economic growth and encourages technological advancement. Now, if we see the structure of this grid connected system, let us say we have this power grid, and this is very high voltage bus bar, 11, 33, 132 kVA, like that. Then we have to use the step up transformer. Then this is the system, domestic system, which we have, right? This is the domestic system which we have. There are several solar panel connected in series or in parallel, then it is converted into AC, and this AC is feeding to this AC bus, which is convert to higher voltage using this step of transformer and going to feed the supply, right? So this is the system. Now this the advantage of this is that enhance the energy reliability and security. How? Because there are several energy sources, and these sources are feeding power simultaneously, feeding power to the supply system. So this is the advantage. It is having the lower carbon footprint, which I have already discussed in the your advantage of solar panel. All right, all this I have already discussed. Now if we talk about the inverter topology which are used for PV system, then these are the means several researchers are working in this field, which type of inverter is to be used. One of my research scholar recently has submitted the PhD thesis. We have operated the open and winding based transformer. There means the uh, primary of the transformer is feeding by the two inverters, right? See, for example, you have a three wire of three phase supply of the transformer. Now what we did, we just open on the connection of that three phases. So totally we have six phases, six terminal of three phases, and both side we are feeding the power. There we get the three level inversion operation simply by using that two level inverter. So that is the good thing which could be explored further, right? So the role of inverter is the you can say it is the brain of renewable energy. Why? Because it provides the load requirement and interfacing with output of the converter. Means what it means? It means exactly your inverter, it takes input from your solar panel DC and convert it into AC so that it can be fed to the supply system, right? So this is the role of inverter. Now the type of inverters are, it could be grid connected string inverter, it could be grid connected central inverter, it could be micro inverter, it could be multi-level inverter, it could be grid connected inverter, transformer less inverter also there, right? Like matrix inverter and all. Then grid connected isolated inverters are there. Then multi-state isolated micro inverters are there. These are the various type of inverters which can be used. And this is the complete block diagram of typical grid connected PV system which we have taken from reference number 13. There is a solar array which you can see. There is this solar array is there. From there we taking DC voltage and fed to the DC-DC converter. The converter is operated on basis of maximum power point tracking technique, and it generates the constant DC link for the inverter, which always operate at the maximum power point. That is the thing which you have to ensure. Then we have the DC to AC inverter, means of course the inverter, it could be multi-level inverter, it could be series inverter, or it could be micro inverter. Any type of inverter could be used depending upon the your requirement. Then to operate this inverter, you have to use the PWM signal, and these PWM signals are generated depending upon the requirement of grid control. You take the voltage and current from the grid, and DC link voltage from here, DC link voltage from here, from here. Then depending upon the control strategy, it will generate the PWM signal for the inverter, so that this inverter is operated. And this output voltage, even though it's only two wire is shown, if it is a single line diagram, there would be three phases, right? And this is fed to the filter. and after filtering means the lower order harmonic has to be filtered, then it is fed to the grid. It is fed to the grid. Here you can see this is the how the grid integration of the solar panel could be done, right? Now these are the various PV inverter topology. I am skipping this because these are very simple and you can go through by the literature. So I am not going to discuss these. I am just skipping. I am just skipping these topologies. These are very simple topology because I wish to show you the simulation result and all. That is why I am skipping. In case if you have any doubt, you can ask me now. In case if you have any doubt, you can ask me now. Moin sir, I am allowed to skipping all these slides?
Yes, sir. Yes, sir. Afterwards, we will share this slide to students. So,
No,
actually,
no.
these are
For Moin sir, for benefit of the student, I have already live streamed
yes,
this. You can
yes,
share
yes,
that link to the student as well.
yes, yes, sir. I have seen.
Okay.
Okay. Thank you.
Right. So I am just skipping this. Now I'll like to more about the PV system grid integration challenge. See, you are producing your own energy. Grid is having its own system. Now there are what you wish. You wish to fed the source which you have. That means the solar power that to the grid. So the various challenges you have to face. What are these challenges? These are the variable generation means the intermittent nature of the solar power affect the grid stability, efficiency and reliability. Suppose that grid is operated at some other frequency. You have to have those frequency. Your inverter has to operate at that particular frequency. Then only it can be fed to the grid system. Efficiency is the another challenge, right? So these are the challenge which you have to face. Other is protection related issue, safety concern, that grid is operated by very high voltage. You have to install the transformer and all, or the authority has to install those transformer. Then you have to have that protection of the high voltage and current for the user, right? Then mitigation technique, if you think about this, then the various strategies are used to mitigate these challenges. And those are given in the reference number 64. Now talk about the output power prediction. Means you are feeding power to the grid and suppose grid doesn't require that power, then you have to ensure how much power you are going to feed to grid, right? So the old grid, those who are working in the load flow forecasting and all, they know how challenges it is. You have to forecast the load, means load requirement, so that the energy generated at the various point can be diverted towards your load, right? So traditional grid have demand side uncertainty, but now in today's era, when we are integrating the renewable energy sources with grid, that has to be taken care of. That demand side as well as generation side also, because suppose demand side doesn't require any energy and generation side keep on taking power from the various sources, there this power will go. It is not going to store at the grid side, right? So that type of thing has to be taken care of. You have to tell the authority. Authority means your power receiving or generating an authority, how much energy you are going to feed tomorrow or how much power you are going to use tomorrow. That type of thing is taken care by in smart grid technology, right? Then climate impact, that the temperature and the solar radiation of the sun that directly affect the PV generation. So that type of prediction and how you will handle those things, you should think about this. Then monitoring of the PV cell is the another challenge. right? That modeling has to be done. That means this how this current source based this PV cell modeling could be done, right? Then there are also uh, challenge how this affect the series and parallel combination of this cell and this climate factor of this power generation affect this series parallel combination. All those challenges has to be taken care of by the researcher, right? This is the scenario, although this wind is not we are going to discuss, but here you can see how in globally that installed wind power and the PV power, you can see these two are going neck to neck, means solar is approaching towards wind. Solar is approaching towards wind in the initial means somewhere around 2011 the gigawatt all these capacity are in gigawatt. There is a huge generation of energy through wind, but solar was very less, and slowly it is increasing 70 100 138 78. Now it crosses in 2020, it has been already crossed the wind generation in 2020. Right? So I have taken data only up to 2020, because nowadays it is the huge advancement and the installation capacity in the solar. And now everybody knows I am only showing the historical data. Means 6 years back data I am going to show you. Right? So that type of thing has to be considered in mind, means costing depending upon the year by year how it is going to reduce. If you see, it clearly show the advancement in the solar technology. You can see during 2009 it was around 359, right, dollar per megawatt hour, but now it is reduced drastically somewhere around 40 41 40 41. You can see how this cost solar power energy generated through solar power is costing is reducing day by day, whereas other sources almost increasing or decreasing in very less amount. For example, if we talk about the gas power, so from 275 to 175, whereas this is 359 to 40. So there is a drastically reduction in the energy cost generated per megawatt hour in case of solar. It clearly shows there is a huge advancement in solar power technology, right? Now, if we talk about the voltage stability, we should think that it requires constant power source for a network. That solar is available only for 3 to 6 peak hour of the sun. Then, after that, what you will do? So that type of thing should be considered. Means you during that period you should ensure to store the energy as maximum as you can. Then you can use when it is not available. Then residential distribution feeder. See, it is clearly indicated by Grant's probabilistic approach that 25% of the PV penetration could cause voltage issue in low voltage. Right? It is the study done by Gantz, which clearly showed this. Now, optical PV hosting, this optical level reduce the power loss, excess capacity cause higher losses and instability. Right? That is the another uh, challenge in the voltage stability. Now, continuation power flow algorithm, it is proposed and analyze voltage stability, and it highlighting the replacement of this PV cell. means when it is deteriorated, it has to be replaced. Then lack of coordination means Wong found uncoordinated PV installation can lead to voltage fluctuation. Means everybody is installing the PV system. Then this is also create the voltage fluctuation. Then mitigation of over voltage. Now reactive power control can be addressed. Can be addressed because if you don't consider that reactive power control, then there might be problem of over voltage if you increase the PV cell installation, PV solar power installation, right? It also taken care of, right? Now, if we talk about the frequency response, then generation generation demand imbalance and ROCF impact, then penetration limit, solar relief effect. All these are common effect which is because of frequency related issue. These are the things which you should consider. Then the system stability. See, low inertia and secondary PV dripping pose significant security threats. See, we are installing a very tiny, very small PV system, right? So its inertia or stability against the overloading is very, very low. So that thing should be taken care of. Mind that it should not trip the system, right? And we should use the optimal control strategy. That means keeping the things MPPT as well as the frequency fluctuation should not be there. Means frequency fluctuation should be minimum and maximum power point tracking should be at maximum. Right? It also consider that how you will support the reactive power. Whenever this DC power is all generated by solar cell, it is the lack of reactive power, right? So how you will inject this reactive power? How you will inject the reactive power? Researchers are also working on that, right? So wind and solar power can also contribute the reactive power because in wind case there is an induction generator being used, right? So how these two things can be contributed in the reactive power, that is very interesting research area, right? Then there are several grid codes and devices which are being used for along with this PV interfacing with the grid. Those are the things which could be seen and fine. And then another problem is related to your power quality, means the harmonic, the power related to harmonic. See, when power electronics converters are used, they inject the harmonic. So you have to have reduced the eliminate the harmonic, especially the lower order harmonic. That is very dangerous. So you have to use some damping equipment or filters are to be used. It could be active filter, it could be passive filter, it could be LCL filter, which reduce the TSD from 30 to 3.9. Means it reduce the higher lower order harmonic. But at the same time, you should consider the think over the size of the filter. What would be the size of filter for that, right? And also, if we talk about the frequency, then angular stability has to be come that the transient stability. There should not be any oscillation. There should be small signal stability. As the bulk PV penetration, it also very critical for a small signal stability problem, right? So that also should be considered. Now, if we talk about the solution of this technique, the techniques which are used for reducing all these things, it could be coordination method. Means how active and reactive power coordination in PV inverter. The control strategy should be developed that how we can control the reactive and active power, right? And then fact devices could be used wisely. Then STATCOM, all these are related to power electronics. Application of power electronics in power system. Those devices should be used wisely, right? And then fault and low voltage right through capacity, right? Then this are the various facts which are being considered. For example, transformer-less PV inverters. Why they use widely? Because of they are having very high efficiency and FRT and LVRT features as well. Then anti-ice lightning protection. May see suppose you're all of a sudden you disconnected from the grid system, then how you will survive? That type of the situation should also be considered, right? All these things are needs to be considered. Then protection challenges. What about the vulnerability of the with faults? Right, they our PV cell is suspected to for various type of fault, and how this fault impact our reliability, efficiency, and safety of the grid. We should think about that. Then, apart from the conventional standard, we also develop some new challenges, especially when we are using the power electronic devices which are having the non-linear characteristic, right? Then wavelet transformation, that online fault detection algorithm for grid integration PV system is being nowadays used, right? Now, electricity market challenge, that is the another aspect. See, you are generating the power. The entire game is on the basis of demand and supply. The entire game is based on demand and supply. Now, how you will fix the pricing? Power generation uncertainty. That is the if power is generated, then it has to be consumed. So demand should be based on the tariff should be based on the demand, right? So we have go for competitive pressure. Right, that is the government gives the incentive for putting this PV cell to the consumer. If you install the PV panel, solar panel, then there is a subsidy from the government. Why they are giving? They are giving this subsidy just to promote this solar cell, so that that the cost which is involved for this fossil fuel, that is quite high as compared to the solar. So if we providing subsidy and user install the solar panel, they will use less electricity generated by the fossil fuel. So overall it is the advantage for the government. That is why they are giving us, right? And there are market feedback framework also come in the picture. That is also incentive based. Then bidding strategy, that the worst case scenario and the average profile strategy to manage PV power generation uncertainty means you can bid, right? You can bid yourself, and the supply is based on the bidding. Lowest bidding would come in the uh, picture, right? So this is the all economical term, technical economical and related to economics, right? This I have already tell you. Now for this, what we have to do? We have to change the citizen perception, that we have to make people understand that the coming future is only on the base of renewable energy. So they should move towards that, right? We should increase some awareness program, right? And then we should promote the feed-in tariff, net metering incentive, means how much power you are giving to the supply system and how much you are using, that is the net power metering, and you will reduce, you will charge at the reduced cost. So this type of things should be taken care of. in the PV cell integration with grid. Right? We have also developed that some grid codes means there is some guidelines which are very safe and efficient to inject power from to grid and taking power from grid using the non-conventional energy resources like solar. Right? Advanced control strategy should be used. Then we should think about the energy storage system. We have to use the battery and the other storage technology to balance the supply and demand. As I stated earlier, that there is a game of supply and demand. If suppose you are generated some huge amount of solar power, but your demand is very less, then what you will do? You have to have stored that power to some batteries or some other places means which are used to store the energy, so that when demand is high you can supply that. So that type of thing has to be keep in mind, right? So this is the region where we should operate. This is the region where we should operate. That the voltage variation should not go beyond this. Right? So these are the reason where we should operate. Now the purpose of grid code means that only rule and regulation. The only purpose is to ensure the safe, secure and reliable and economical operation of electricity grid whenever we connect solar with grid. Then grid code differ by country based on the specific requirement. For example, in India, the frequency is 50, whereas you go to the US or European, then you find that the frequency is 60. So, grid code or the grid rules is changes depending upon the country. Then the integration, that the global how renewable energy source like PV system integrate into national grid. That is ensured by the grid code. And frequency variation is also ensured by the grid code, that how much frequency variation can be accepted when you interface with the grid. Then fault died through capacity. How much the load it handle, or how much the fault right through capacity means if some fault occur uh, because of your PV cell and all, then uh, how much voltage dip is allowed? Means suppose it is 240 and for the 2 or 3 cycle it is goes to 200. Is it acceptable? Yes, if it is acceptable, then go through this. Otherwise, system has to be tripped. That is called the five right through capacity that we have to take in care of. Then voltage versus time graph and NDRT requirement are needs to be checked. Then, as I have already discussed, feed-in premium means additional payment you have to pay when the demand is very high. For that, feed-in premium policy is applicable. You have to charge extra amount, right? Investment tax credit means it reduces the tax liability to encourage the investment. If you install some solar, then there is a reduction in the tax liability as well. That amount is free from the tax. That type of incentive should government provide, right? So these are the various incentives which are given by the bank, like low interest bank loan is available. Then national renewable energy targets is very high. We have to install the more and more non-conventional sources. So for that, we promote this net metering system and the green certificate, and this capital subsidy is given by the government. Then these are the some country specific policies. In Germany, FIT is applicable. That means Germany, France, and Belgium. These are giving the this FIT best, that is feed-in tariff. That is feed-in tariff policy, right? That means long-term contract based on the generation cost. It is very successful policy and it is applicable in the Germany, France, right? UK is combines with QS and FIT scheme. USA is Mars LCP and ITC, and the third party financing policies are applicable. China again follow the FIT policy. Now, I will like to tell the one real example of integration with microgrid, which my student have did the project on this, and we get the UPCST grant for this project. See, this is the battery, right? This is the battery, and this is the solar cell. So this solar cell power can be stored in this battery, and this is our DC bus bar. This is our DC bus bar. See, this DC converter is being used, means power can flow from here to this side as well as from here to this side. Both side power can be flow. But here it is not possible. You cannot give the power to the solar cell. It is always unidirectional from here to here. It is also from here to here. Then we have DC converter, which is used to generate this constant DC link voltage, which is used to for this constant DC link voltage. This converter operates at MPPT, maximum power point tracking, and this converter operates at depending upon the load voltage. So this is the complete system, and we have developed this in our university. MPPT is developed for controlling the energy storage, energy extracted from the solar panel, and this uh, MPPT along with boost converter we have used, and this is the simulation model of this energy storage along with the boost converter model. This is the solar panel, and this is the boost converter. Those who are working in the field of power electron, they can understand these are the very simple circuit, and this is the load, DC load is there, right? And this is the control strategy for maximum power point tracking. It will generate the PWM signal for the this chopper, which can be which ensure the maximum power point tracking of the solar. And here we can see, depending upon the various irradiation, we are having the same. I mean, always operate at the maximum power point. Always operate at the maximum power point. Right. So this type of thing you can also develop at your institute, and these are the simulation results for various temperature and irradiation that the bus current at 1000 Weber square per meter square radiation and temperature of 25 degrees centigrade. This is the bus voltage for the same irradiation and the temperature. This is the power at 1000 Weber square and 25 degree. Now we have also developed the strategy when battery is to be charge discharge, or this power is taken from the solar itself, right? And when it is taken from the battery. So for that we have used the simple potential divider rule, and depending upon the voltage and current sense, we operate these switches. When this switch is operated, it battery get discharged. When this switch is off and the switch is on, we get the supply from this battery to this load, right? And when this switch is on, we get the supply from the source, and this battery is also charged, right? So that type of thing we have developed and successfully also investigated on the real-time simulator of Opel RT, right? This is, you can see the exactly the same voltage and current we are. This is the state of charge of the battery. Just show me the state of charge of the battery. It is the charging mode. Only within 3 seconds you can see it is reached from 45 to 45.03%, right? Within 3 seconds, that is the state of charge. Then this is the power discharging mode. Then state of charging during the discharging from 45 to 44.84 within 3 seconds, right? We discharge this using the huge amount of current, right? And then we talk about the A real-time simulator. In this, we have used Opel RT real-time simulator and are operated in hardware in loop testing. We have generated the control pulses using this Opel RT simulator. We have uh, this system at our hand. We have this system our hand, and this is the host PC, and through Ethernet it is connected to this. Yeah, we are having a 2-core Spartan board at our end, and this is the master block, and this is the console. Means whatever the power circuit and control circuit, you have to put it here, you have to put it here, and only display is put in the console. The display and operator panel is available in the console during the real time operation. So in this way we have get this DC link voltage, although there are ripple, it is without the filter capacitor and all. For various firing angle we are getting this, duty cycle we are getting this. They have done is for just to test the model, they have operated in the with the AC supply and getting the rectify output voltage. That inverter is operated as a rectifying mode, right? So these are the simulation result for those. And after this is the model, how the real-time simulation model can be developed. This is the core ID, board ID and all that has to be put here. Then this is the op control block that has to be put, and the entire block is put in the SM master. Then SC console will give you the result. Here you can see these are the real-time PV output. Real-time PV output you are getting. This same. And simulation, if you remember, we are also getting the same thing. Although in the hardware we found some ripple, some small variation in the output voltage and current, but that is very, very less. And see, it is also tested at less irradiation. That in the simulation it was 1000 and here it was 7500, and we get the similar result which was expected. We get the similar result which was expected. And we have developed one more model in this real-time simulator. As we have 2 cores, so what we did, we have developed our plant on the master, controller on the another board, that was the SS. SS stand for slave, and SM state for master system slave, and this is the system console, right? SM, SS and SC, these three are the system. This is the SM master. Inside SM master we have put it this. Inside slave we have put it this. This is the control block. Here you can see the MPPT coding and everything is here, right? Then after that, this is the console. Console, you have only the operator panel, means you can change the radiation from here to there, right? You can change the temperature from here to there, right? And then we have these signals are coming from the master, and you can see the various parameter on the scope. On the running time, only console is available to you, and these are the state of charge in the real time mode recorded on the DSOX 2024, right? So these are the simulations result, right? And for hardware implementation, we have used chip SN3722 MPPT controller. And then the current sensor which was used is ACF712. Then voltage sensor module AD202 is we have used, and microcontroller ESP32 we have used to develop this model. Right, and this is the developed model. Here you can see this project is being generated by my BTech student. Hardware implementation of this PV integration with the grid. Right. So this is the various voltage and current measured from the PV panel. Then if we talk about the conclusion of this talk, that we have studied that the global energy demand it cannot be met out without the using the this non-conventional energy sources. Then the solar PV benefited, these are the cost effective, they are very efficient and incentivized by the government, right? Then the integration challenges, various integration challenges are still there. Intermittent generation, then the output prediction, then voltage frequency and angular stability is related issue, then harmonic related issue, and then limited fault right through capacity of the solar power, right? So, and if we talk about the economic and environmental barrier, this is the transmission congestion, market access, and the socio-environmental means the use of this batteries and this solar panel, the wastage adjustment or wastage utilization of the reuse of these solar panel and all those things. Waste management is the another big challenge with this technology, right? And we have also studied the various potential solution that the AI based, now everybody is talking about the forecasting. So AI based forecasting for this, it could be the another research area or the BTech project Asia for BTech project area for our student. Then we also do some project on the advanced inverter. It could be multi-level, it could be open and winding based inverter and all. We can also work in the field of smart grid. And then energy policies are also look onto. That is the trailer grid codes, financial incentive, distributed generation promotion, and ancillary service mandates. Right. These are the some research gap which I found, that the hybrid system could be used, advanced inverter could be used, social economic studies is another area of research. Then integrated energy systems can also be used. These are the various research areas where the work has to be done. And if we talk about the various reference, these are the list of reference which I have taken to make this. In fact, our research student and our BTech student made all this under my guidance. So they have used these research papers somewhere around 180, 149, right? And this is my contact detail. I have shared my Instagram ID. This is my Instagram ID, and I have also shared my WhatsApp number. In case of any problem or any query, you can contact me directly. And this is my LinkedIn, so you can scan this. And this is the live channel where it is being recorded, so you can have it. Just this is the channel where you can see our recording is going on,
Uh, yes,
right?
thank you. Yes,
So
sir.
thank you from my side. Over to you.
Yes, thank you so much, sir. And I have seen you have started your expert talk from the fundamentals and intermediate, then gone to the simulation results and reached to the hardware models. And it is very amazing to see your BTech student had made such a very good hardware model. So, and you have also mentioned here several gaps and research opportunities for our students also. So really, it is a very good presentation. So it is very beneficial for us. But now I would like to invite students. You have listened this presentation, and I am very happy because we have started from the 65 participants, and still there is 64 participants. So,
It
sir, you
might
have
be two
connected.
reasons, Moin Saab. Either it is that because of terror of you, or that
No, no,
of
no, 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 not like that, sir. Not like that. So, students, if you have any question from the Sanjeev sir, then you are invited to ask. Please, we have 5 minutes. अगर किसी स्टूडेंट को कोई क्वेश्चन हो, then you are most welcome. Yes, Ajit Bharti. Yes, ask your question. Turn on your camera. Turn on your mic. Mic only. Your
अजीत,
wife. अपना अजीत
बेटा
अपना कैमरा
घबराओ
ऑन
नहीं,
करो.
हम तुम्हारे साथ हैं। हम
कैमरा ऑन
विशुद्ध
करो.
से टीचर हैं, और तुम हिंदी या अंग्रेजी, बच्चा जिसमें चाहो उस भाषा में पूछ सकते हो। यू
पूछ
कैन
लो
आस्क
कैमरा.
योर क्वेश्चन।
अपना माइक ऑन करो अजीत. अच्छा ठीक है. अजीत का ग्रुप में टाइप किया है तुमने क्वेश्चन?
हेलो.
हाँ
हाँ
बेटा
जी.
बताओ।
गुड आफ्टरनून सर.
वेरी गुड आफ्टरनून।
तुम्हारी वॉइस आ रही है, पूछो अजीत, कुछ पूछना है तो.
सर मैं
यस यस, यू आर वेरी मच ऑडिबल।
हेलो.
यस।
हेलो.
हाँ तुम बोलो अजीत, बोलो, सुनाई आवाज आ रही है.
हेलो.
आवाज आ रही है, बोलो बेटा. चलो मैं पूछे ले रहा हूँ, मैंने तुम्हारा क्वेश्चन पढ़ लिया है. हाँ पूछो, पूछ लो.
हेलो.
चलो अच्छा, नेटवर्क इशू है, मैं पूछे ले रहा
सर मैं
हूँ.
ऑडिबल.
हाँ ऑडिबल है, पूछो क्वेश्चन जल्दी से.
सर मैं ऑडिबल.
हाँ ऑडिबल हो यार, पूछो तो. सर अजीत ने ग्रुप में क्वेश्चन डाला हुआ है.
जी जी।
अजीत पूछना ठीक है तो अपना माइक ऑफ कर लो, मैं पूछे ले रहा हूँ. ये पूछ रहे हैं कि सर जो ग्रोथ हो रहा है स्मार्ट ग्रिड का, बैटरी स्टोरेज सिस्टम का और इलेक्ट्रिक व्हीकल का,
जी,
तो आप आज से 10 साल बाद इंडिया में सोलर पावर इंटीग्रेशन किस तरीके से देख रहे हैं? इंडिया का क्या फ्यूचर है, कैसे प्रोस्पेक्ट?
बेटा अजीत, ये तो आप खुद ही देख रहे होंगे, मोदी जी का विजन ही है।
हेलो.
हाँ बेटा।
चलो तुम रहने दो, मैंने पूछ लिया है, सर आंसर कर रहे
अजीत
हैं.
को आवाज क्लियर नहीं है लग रहा
हाँ
है।
नेटवर्क इशू होगा सर.
जी।
ये
So, see, there is a huge growth of solar power, which we can see. It is the vision of Modi ji. बेटा कुछ या तो माइक ऑफ कर दो।
अजीत अपना माइक ऑफ कर लो, मैंने पूछ लिया है.
हेलो.
बताओ भैया।
सर माइक ऑफ कर दिया है टीम ने, अब आप आंसर कर दीजिए. टीम ने माइक ऑफ कर दिया.
अजीत, जो तुम सोलर पावर की बात कर रहे हो, तो आज की डेट में जो है 157 गीगावाट का जो है हम लोगों का लक्ष्य है, आज की डेट में है, राइट। और ये इसका जो एक्सपेंशन है, एक्सपेंशन रेट 51% है। तो आने वाले समय में ये एक वेल इस्टेब्लिश टेक्नोलॉजी होगा, ऐसा मेरा व्यक्तिगत रूप से मानना है। और आने वाले समय में हम लोग सोलर को यूज देखेंगे, और अभी देखना शुरू कर दिए। और ये सेकंड वर्ल्ड का सेकंड लार्जेस्ट कंट्री हम लोग बन चुके हैं
और
इस
लखनऊ
क्षेत्र
तो
में।
टॉप पे आ गया है सर।
ठीक है,
लखनऊ।
तो तुम तो भैया लखनऊ निवासी हो, योगी जी तुमको कहाँ छोड़ेंगे, राइट। कुछ टेक्निकल अजीत अगर पूछना हो तो वो पूछो, ये जो इट्स टोटली डिपेंड सी। जैसे आज की डेट में हम लोग इलेक्ट्रिक व्हीकल की बात कर रहे हैं, पीपल स्टार्टेड परचेजिंग दैट इलेक्ट्रिक व्हीकल एज वेल, बट स्टिल देयर आर ए ह्यूज चैलेंज ऑफ चार्जिंग, राइट। तो दैट थिंग्स आर टू बी डिस्कस, और कभी और लेक्चर में करेंगे, लेकिन आज की डेट में भी करा जाए तो इसी पीपल
लंबा
स्टार्टेड
हो
चार्जिंग
जाएगा।
एट देयर होम, और फिर हो क्या रहा है कि वहां पर आग लग रही है। अभी कुछ दिन पहले पेपर में ही न्यूज थी कि चार्जर लगा दिया साहब और उससे आग लग गई। तो जब जब टेक्नोलॉजी का इवोल्यूशन होता है तब तब कुछ ना कुछ चैलेंज आते हैं, एंड स्लोली स्लोली दैट टेक्नोलॉजी इज मैच्योर्ड। तो अभी जो
यस।
है हम लोग काफी अच्छी स्थिति में है, और ऐसा मेरा व्यक्तिगत रूप से मानना है कि आने वाले समय में सोलर गेट मोर एंड मोर अटेंशन टुवर्ड्स फ्रॉम द पीपल।
Yes, thank you so much, sir. Now, Akansha, it is over to you.
Okay, sir. Thank you, sirs, for your inspiring and insightful address. Your words have truly motivated and enlightened us. Now it is my pleasure to invite Dr. Khadim
Nice.
Moin Siddiqui, sir, to invite Ashish Singh, sir,
So,
for his.
Akansha,
Yes, sir.
Ashish sir is traveling. Okay, Ashish sir
Yes,
sent
sir.
message. He told me
Yes,
convey
sir.
the best wishes for the students. I am
Yes,
traveling,
sir.
therefore signal is not coming. Okay, network is not
Yes,
there.
sir.
That is fluctuating. So he will join in any momento. Share कर दो e momento.
और एक ग्रुप फोटोग्राफ हो जाता तो बहुत अच्छा
हाँ गुरु
रहता।
सर, गुरु फोटोग्राफ वोट ऑफ थैंक्स अभी करेंगे पहले।
कम से कम इन बच्चों को हम देख तो लेते।
अच्छा, दोनों का सर का भी बना दिया था आशीष सर का, ग्रेट। तो सर ये ई मोमेंटो है हम लोगों की तरफ से आपके लिए।
धन्यवाद साहब, धन्यवाद।
और इसको हम लोग आपको शेयर कर देंगे, वी विल शेयर इट। और अब इसके बाद वोट ऑफ थैंक्स होगा, और वोट ऑफ थैंक्स के बाद सभी स्टूडेंट्स अपनी ग्रुप फोटोग्राफ के लिए अपना वीडियो ऑन कर लेंगे जब कहा जाएगा। So I am going to propose a vote of thanks. So good afternoon everyone. As we come to the end of this wonderful IEEE PLS Day 2026 celebration, it is my privilege to propose the vote of thanks. First, the foremost, I express my sincere gratitude to our chief guest who has not joined today, but he has sent us best wishes, Professor Ashish Kumar Singh, sir, who is the chairman of IEEE PLS chapter, IEEE UPSEC, sir, for giving us best wishes for this program. So he has not joined the program due to his problem. And further, I would like to extend our heartfelt thanks to our esteemed speaker, Professor Sanjiv Kumar Singh, sir, HBTU Kanpur, for delivering
मेरा
an
नाम संजीव कुमार है, संजीव कुमार सिंह नहीं है।
नहीं, संजीव कुमार ही बोला है सर। प्रोफेसर संजीव कुमार, HBTU Kanpur, for delivering an insightful and enriching lecture on the integration of solar PV system with the grid. His expertise and valuable perspectives have undoubtedly enhanced our understanding of this important and rapidly evolving field. I sincerely thank the management of SR Institute of Management and Technology, our HOD, directors, sir, faculty members, IEEE volunteers, organizing team members, and all participants for their enthusiastic support and active participation, which made this event a success. Finally, I thank the IEEE Power Electronics Society and IEEE UP section for their continuous encouragement and support in promoting technical learning and professional development. I hope today's celebration and technical session have inspired all of us to contribute towards a sustainable and energy efficient future. Thank you all for your time and participation. I wish you a wonderful day ahead. Thank you. Now I request to all the participants, please turn on your camera. and I am also turning on my camera. So सभी पार्टिसिपेंट्स अपना कैमरा ऑन कर लेंगे ग्रुप फोटोग्राफ के लिए. प्लीज वेट कपिल, जब कहा जाएगा तब उस टाइम पर लेना, अभी नहीं. Yes. Now Kapil, Shreya, Nabila, you all take group photograph. Done.
मोइन साहब, मैं दो जगह से ज्वाइन हूँ, एक में कैमरा नहीं चल रहा है, एक में चल रहा है. तो
कोई दिक्कत नहीं है सर.
हाँ, तो जो भी हो तो वो अपने एंड से मेक श्योर कर ले.
आकांक्षा, एक ग्रुप फोटोग्राफ तुम भी ले लो. Okay, done. So, sir, we have taken a group photograph, and with your permission, if you
बिल्कुल, श्योर.
then we can end this program.
Thank you, Moin साहब, for inviting me. Thank you very much.
Thank you so much, sir. Thank you so much for giving us your precious time.
Thank you.
Now, with the permission of guest of honors and experts, sir, now you all can leave this platform.